In this video we are going to do exercise 3.2 and we're starting from question number 1. So in the first figure it's given that DE is parallel to BC. So in this first one it's given DE is parallel to BC in triangle ABC. So by BPT theorem we can say that AD by DB will be equal to AE by EC. And from here we can say that 1.5 by 3 will be equal to 1 by, let's suppose EC is A here, by A. And if we cross multiply we will get 1.5A is equal to 3, and from here we can say A is 2. Now in the second figure, again in triangle, in the second this figure it's given that DE is parallel to BC. And again by using BPT we can say that AD, let's suppose this AD is x by 7.2 will be equal to 1.8 by 5.4, and if we do cross multiplication we can say 5.4x is equal to 7.2 into 1.8 and divide 5.4, 7.2 times 1.8 by 5.4, we can cancel out by 3 and it will be 2.4. So it means AD is equal to 2.4 centimeters. Okay, now let's do question number 2. In this question it's given that E and F are points on the sides of PQ and PR respectively of a triangle PQR. So here it's talking about a triangle PQR. And E is on the side PQ and F is on the side PR. Let's do the first part here. So the first part it says that PE is 3.9 centimeters, EQ is 3, PF is 3.6 and FR is 2.4 centimeters. And we have to prove that EQ, we have to check if EQ is parallel to QR or not. So to check if the EQ is parallel to QR, we will use the converse of BPT. So the converse of BPT means if we prove that PE by EQ is equal to PF by ER, then by the converse of BPT theorem we can say that the lines EF and PQ are parallel to each other. So let's check here. It's 3.9 by 3 and it is 3.6 by 2.4. If we simplify this will be 1.3 and this will be 3 by 2, or we can say this one is 13 by 10 and this is 3 by 2, and since these two are not equal, so the line EF is not parallel to QR. Okay, now in the second figure, in the second question, let's draw a triangle. Again the triangle is PQR. It's given E here and F is on the side PR. PE is given 4 centimeter, QE is given 4.5, PF is 8 and RF is 9 centimeters. So let's check with the converse of BPT theorem. 4 by 4.5 and 8 by 9. Let's remove the decimal here. So we can say it's 40 by 45 and it's 8 by 9. So 40 by 45 we can say we can cancel out with 9. So it's 8 by 9. So hence the ratios are equal. This implies that EF is parallel to QR. Okay, now let's do the third part here. In the third part we have to draw a triangle once again. Triangle PQR, EF. Now here PQ, this time this length, the whole length PQ is given 1.28, PR is given 2.56, PE is given 0.18 and PF is given 0.36. Now if we prove that PE by PQ is equal to PF by PR, then also we can use the converse of the BPT theorem. So from here we can put the values. We can say 0.18 by 1.28 and 0.36 by 2.56. So if we check these, we have to prove these two are equal. So we can cancel out this one with the 9. We can first remove the decimal, so it will be 18 by 128 and it will be 36 by 256. Then we can cancel out this with 9 and it will be 64, and this one we can cancel out with the 4, 9 and it will be 64. So the ratios are same. It means that EF and Q are parallel in this one too. Okay, now let's do the question number 3. In this question, this is a figure given. LM is parallel to BC and LN, this side LN is parallel to CD. This is D. And we have to prove that AM by AB is equal to AN by AD. Okay, let's first take the triangle ABC. It's already given that ML is parallel to BC. So from here we can use a BPD theorem and we can say that AM by AB will be equal to AL by AC. Now in triangle ADC, it's already given that LN is parallel to CD, and again by using BPD we can say that AL by AC will be equal to AN by AD. AL by AC will be equal to AN by AD. If we look at these two equations 1 and 2, from here if you observe AL by AC is equal to AM by AB, and AL by AC is also equal to AN by AD. So from here we can say that AM by AB will be equal to AN by AD. Hence proved. I hope this video was helpful to you. Don't forget to like and share. Thank you. Hello students. Today